record some of my latest notes. I wrote a lot in September, just this, even though it's only September 22nd, 2018, 6:09 p.m. Still about 10 days left in September, but I've written a lot, and especially because I read one article by Max Born on the question of how to make subjective knowledge objective, which is very important. Also, I have some notes on Hegel, and I have some other notes, but mostly it's like 90 pages of Max Born to think about. I'm going to read very quickly because I have a lot I want to get all of it, and most of the time I read slowly and I add comments, so it's too slow. I'm going to try and read very fast this time, just to see how it is different. But it's very hard to read because these notes are handwritten by Joseph B. Jones. It's hard. In other words, I wrote, but it's hard to read because the words were quick. I wasn't trying. Okay, I'm going to try and read very quickly. Okay, we'll see how that goes. Okay, so the first page is on square methods, September 21st, 2018, another after midnight, 12:34 p.m. Add quantum geometry as a super method, whatever that is. It must refer to geometrical figures and use the set of integers for points instead of the set of real numbers or set of complex numbers. Newton used Euclidean geometry and Einstein used non-Euclidean geometry, but really both are with continuous variables. What purpose is it for? Hawking had theory of quantum gravity, so GR, which is really about gravity, as related to space-time geometry, may require quantized geometry for Hawking's theory, but they can't unify Euclidean geometry and algebra. So who unified non-Euclidean geometry and algebra? Was that what Riemann did? So you have to unify quantum geometry and algebra, or discrete algebra, i.e. eigenfunction algebra. Quantum geometry and differential integral calculus, or quantum geometry and differential equations calculus, or these divided differences, or integral equations. See the movie Good Day Hunting on mathematics. Or did you unify geometry, tensor calculus with discrete variables, or partial differential equations, geophysical equations of digital. Okay. I'm reading a lot, maybe it's not so bad. Watch the debate on Monday between the four candidates for the leadership of Quebec, including the Premier Louis-Albe. And I saw that actually they had to read a lot. They didn't have something in front of them to read, so they're not looking at the camera sometimes. They were reading, it seems they were reading from paper or something. I don't know if they got questions beforehand, which might be a good idea, because you need time to think about these questions. Anyway, they were reading also sometimes from paper, so maybe it's not so bad. But they did look into the camera also. I mean, when you do the news or something, I think you have cue cards in front of you so you can look into the camera. Okay, also there is some notes on Max Born. This is very important because this is quantum mechanics, and we can see very different from Einstein's general relativity in some ways. People know Max Born, September 20, 2018. Okay, so I still have notes before this, but this stuff is not secure, so I'm going to do that first. Paul McCartney concert tonight in Montreal here. Tickets sell from $300 to $400, $500, $600, $700, $800, $1,000, $100,000, $200,000, $300 flat tax at the Bell Center. It's on Montreal Canadiens Road, I think, downtown. Okay, so is that it? Really? Is the real problem in atomic physics not the problem of causality, but is simply that physics is capable of answering that question scientifically because of Heisenberg's uncertain relation? You disturb a particle by observing it, but really the solution may exist in philosophy, though Max Born criticized it, and philosophy did not solve that, philosophy did not solve the problem. And since Kant may not be the final word, even if he thought it could not be solved, and his word was the final word on the subject. But really, is the key to the solution the many-body problems inside the atom, since physicists only consider the two-body problem of the neutrons in nucleus, if the electrons in orbit, but only consider one electron at a time, so have a nucleus to electron attractive force of Coulomb only. They neglect other forces or electrons, each other, or the nucleus is simultaneous. This is my theory, just started. Why there's a problem with quantum mechanics, or unification, or whatever. Paul McCartney concert tonight, continues Max Born. So really quantum mechanics describe the atoms and need to consider the many-body problem. This problem Newton had to be beyond his ability. Maybe this problem is not important in the cosmic scale, in the cosmos, because of the great distances, and the G field is the weakest field, we say. But it matters inside the atom. where you have the electric field and magnetic. And really, they made progress in any body problem by methods of approximation recently. But philosophically, what are the real consequences of this? Can this allow us to know the atom? Quantum mechanics just ignored causality since they could not accept it as principle. Experiments also seem to show that the law of causality was broken, so that you have to add chance. Really, it may simply be that have electric field all around the particle that is moving, and atoms and other charges, and they also have electric fields or even magnetic fields due to motion. They did not consider that, let alone today we know small objects can execute algorithms. Rocky songs came on a song I of the Tiger was on the radio. My theory, okay. So is the real problem in atomic physics not breakdown causality, but rather multiple causality instead of the assumed causality of Newton, Maxwell, Coulomb, or Einstein, etc., or maybe superstring theory, Witten, and Yaw, etc., or Green. So today there is even research into quantum computers, and even very small things make decisions. Okay, so we don't know Max Born, but in case so. After GRFQM, consider uh, why many books. Oops, my mistake. A possible postmodern philosopher. It seems there is a major philosopher who considers the problem of free will and determinism after modern physics. That is E. Cassirer, book 1937. But Max Born recommends it. It seems to be a German. It seems to be in German, but an English translation may exist. The title is something like Determinism and Indeterminism in Modern Physics. Born says it gives an excellent account of philosophical research. It seems it even discusses other fields besides physics. There are references to all the great thinkers who have written about this problem, and quotations also. The question of free will. Cassirer study is deep and thorough. Born says his own short survey cannot be as good, not even compares with. Indeed, I think that Cassirer may be a major Kantian and wrote books on Kant where the question of free will was most brilliantly discussed. Einstein does not accept the general view of physicists. He discovered 150 years after Kant. Ernest Cassirer, 1874 to 1945. Once a peek at his book impressed me. A general philosopher of free will. He studied under Hermann Cohen, the founder of a major school of Neo-Kantianism. He wrote many books, but he is not a Neo-Kantian. I saved $1,000 today because that goes to Paul McCartney. He left Germany in 1933 because of the Nazis. In the end, he went several places and ended up in America. Besides Kant, he was influenced by many other thinkers. So what if had other thinkers? Anyways, this might be what I wanted to fill a big gap there. Max Born recommends him. He references many thinkers in philosophy. And he includes modern physics like general relativity, I think, and quantum mechanics, which is good because I think even Cohen left it out and other philosophers. What did Ernest Cassirer? We all know September 20, 2010, Paul McCartney, Montreal. But Born did say that Einstein is the greatest living physicist in 1948, and it implies that he is not as great as Einstein, but he does reject Einstein's physics in favor of quantum mechanics, i.e. probability, which even Einstein says is due to Born himself. Feynman called Max Born the god of quantum mechanics. Become September 2021, 2000 after midnight. I have technical book on superstring theory. This is better. Since first need a good description before put it in mathematics. I have one by Brian Greene, but I saw his mini lectures series on TV. It doesn't seem so good. This guy is a critical figure, it seems. I wanted Ed Witten. He won the Fields Medal and created M theory, unifying five-string theories. But both of them won the Fields Medal, the most prestigious medal in mathematics. Oh God, but is it mostly geometry? GR did Einstein add tensor calculus. 2M did Born add probability. Now does superstring theory add geometry? Didn't Einstein already add non-Euclidean geometry anyway? Also, maybe there have been major new developments in geometry. Calabi-Yau manifolds. and this is a book by Yo. Yo, a geometer, proved the existence of these manifolds in 1976. Partly only for that, he got the Fields Medal. Now he is at Harvard. Book is copyright 2010, born 1949. Why is Calabi first in the name? Um, well, Calabi is a famous thinker also. I don't know, I don't remember. I just got Yo's book. It was only like $1 or something. September 21st, 2018, Revolution. Olga Kritika, Einstein, GR, and Witten, etc. String theory. But Einstein did a major revolution by getting off the ether in physics, getting rid of the ether in physics. You simply had light traveling through space, maybe partly due to MM experiment. But Einstein introduced another medium to physics, which may not be really there, and many physicists followed him, and his theory is accepted through the QM is considered